Hey everybody, welcome back to the Metal Mill 52 workshop. My name is Bill. This is my shop. We're working on an LBSC Tich locomotive and got a lot of it done if you're following the series. When this week we've completed the blower assembly for the boiler fittings, and there's a lot more than two parts to it, but there's what they call the thoroughfare nipple, which I made out of bronze, that'll go in the front of the boiler. There's also in the smoke box area. There's also the main fitting itself, and then there will be, and I'll custom fit this at the appropriate time, 5/32 inch copper tube that will be cut and threaded on the ends. Here's a drawing from the book. If you're following along, this is what we're making this week. So if you follow along, if you're interested, I'll show a couple of techniques and things that worked well. I'll show an error that I made in trying to make the valve stem. I made it too short the first time around, but it was good practice. So I hope you're doing well. I hope you enjoy this episode. As always, please give me a thumbs up. It encourages me to keep producing these things. If you have any questions, please ask. I'll do my best to answer. Thanks everybody. Hope you have a great week. The next part I want to make is the blower assembly, which is obviously at least two main parts and then a pipe that connects them. I'm going to start with what they call the thoroughfare nipple, and I want to point out that this assembly, once it's in the locomotive, it forms a structural member in the boiler, and I do not want to take this out, do not plan on taking it out, so I'm going to make these parts as you would properly for a permanent part of the boiler and use bronze versus brass. Julia pointed that out. It is a best practice to use bronze for the boiler, although if you read the book, LBSC talks about using brass. Well, I don't have any hex bronze, so I ordered some 3/8 inch bronze rod from McMaster Carr. It wasn't terribly expensive, and my plan is here. I'm going to put this in the lathe, turn down a section. Oh, this is oversized. It's actually like 415 thou outside diameter, and it's called 3/8 inch, so it's oversized, so it won't fit in a 5C collet like it is. I'm going to turn down a significant section of this to actually 3/8 of an inch, and then cut it off so that I can use the 3/8 inch diameter part in a 5C collet, and then use my hex collet block to machine a bunch of this down to a hexagonal shape, a 5/16 inch hex, and then I can start making the part. So I'll show you that briefly. I have something else up my sleeve too, because I'm seriously considering using the PM Research valve body, the globe valve bodies, for this part rather than just making it out of stick, but we'll see. I'll talk about that as we go along. Okay, here's the bronze stock turned down to 3/8 of an inch and the 5C collet that I hope to use to make some hex stock. In the process of doing this, I kind of messed up a short portion of the bronze, and rather than wasting it, I've decided to go ahead right now and make basically the inner half of the valve that will go on the back where the blower is, where I'm planning to use the PM Research globe valve. So this is I machined this piece down, 1/4 inch by 40 threaded, 1/4 inch long, drilled it through with a number 48, and then I pilot drilled it and just finished tapping this 5/32 40. So this will be the part that accepts the pipe that stays inside the boiler as kind of a permanent structural assembly. So now I can take this out, flip it around, and machine the other side. What I'm going to do is leave kind of like a wafer thin division point here, just so that to make it easy to screw in and out of the like an adapter, make it easy to screw in and out of the backside. So this side is machined like LBSC designed. The flip side is going to be machined like John Bailie designed. So I'll show you that in a minute. I've slid the part out. Ultimately, I'm going to cut it off 5/16 from the rim here. So I'm making a 1/16 inch rim, and then a 1/4 inch portion, which is going to get turned down to a 1/4 inch
and threaded, and it's going to have a certain size hole drilled in it for the valve. But before I remove all this, the best way to support it is by using the existing stock there. If you can see that, yeah. So what I'm going to do, I've made my marks with my cutoff tool, and I'm going to just work it back and forth to work that portion down as close as I can get to a 1/4 inch outside diameter before I cut it off. Okay, that worked out nicely. So I've got this part down to a 1/4 inch diameter. I got this nice little rim here. It's a 1/16 of an inch wide. That'll be like the buffer in between the boiler side and the um, valve side here. So all I got to do is cut this off, turn this around. I'll put this in a 5C collet chuck, a 1/4 inch one, because there's not a lot to do. I'm not going to hurt these threads just by threading and drilling this side here. Okay, I said the wrong thing. The inside portion of the adapter is only 150 thou long, so I did have to trim that off, and I drilled it number 30 to accept the larger valve. And so what I'm making here is basically the circled portion. This part will go inside the boiler, and it's been threaded to accept the pipe, the 5/32 pipe that will go in and become a structural member. This is one of the PM Research valve bodies, and I'm planning on using one or the other of these. This is the little machining jig that I've made for them. I showed this before when I machined a T for a prior part for the boiler clacks. So easy to make out of some aluminum. You definitely need this if you're going to machine these things in the mill. So we'll see about that. Now I'm going to turn my attention over, speaking of the mill, we'll go over and see if we can make some 5/16 inch hex stock out of bronze with that first piece that we cut off. The design I'm talking about was published in the Home Railway Journal, a U.S. publication, summer of '09 issue. The gentleman who designed these things, John Bailie, he just recently passed away. The magazine was published by Matt Mason. I don't know if past issues are available, but you could contact Matt Mason. He's active on the Chasqui metalworking group under the live steam part, and he could probably provide reprints of this article. Okay, that came out pretty good actually. I was just checking the fit with my 5/16 inch hex collet, and as you can see, you can only do a couple of inches this way at a time. I tried to do it longer, but it was not having it. I was chewing up the end a little bit, even though I had the end supported. So what I'm going to do is I did cut off the other section. I'm going to leave this together like it is so that I can use this part, get the most out of it that I possibly can, and I'll make the other section as well. Alright, this is a productive evening. Here is the globe valve that's machined with inside the little carrier, little fixture. I haven't taken it out yet, so you and I will both get to see it at the same time. Pretty sure it'll be good. And I've done, again, this is done by the John Bailie method, which is just drilled through with a number 5 drill both ways, and I took still shots, and I'll embed those in this video. It's drilled through with a number 5, which is tapping size drill for 1/4 by 40, and there's the valve, the globe itself. Let me get a rag and wipe that thing off. These things look so cool. That's part of the reason I wanted to use it. It just looks authentic. Alright, so there we are, drilled and tapped 1/4 by 40 all the way through. So this part here
This is what they call the thoroughfare nipple. This will go in the front of the boiler. This is the center part for the valve, and again made by the John Bailie design. So that's how that's supposed to fit in. And this part will go through the back head of the boiler, and it's already drilled and tapped for the 5/32 40 tube, just like this piece is. So those will become part of like an integral part of the boiler. The rest of it, I'll need to make a valve assembly for this side, and then basically just another adapter for the top. Let me show you what I mean when I say a valve assembly. I'm going to use the John Bailie method here. So there'll be a top part like this, a bonnet if you will, and then a valve. And they make, the Bailie design makes the valve out of 3/16 inch stainless steel versus the 5/32, so it's a little more available. So again, we'll see how this works, but I'm excited about the progress so far, and we'll keep you posted.
I had a work trip this week, so I didn't get a chance to work on a lot of stuff, but I did make a list of the next steps I want to do after, we got this far last weekend. I'm going to make the bonnet per the John Bailie plans, and then also make the valve stem by the John Bailie design there, and the little cap for the that goes on the stem, and the nut. I'm going to use some pre-made nuts, so just a few parts to make. Also, I will need to make a custom adapter for the steam intake that'll go into the top of the valve here, because this is the blower valve. So the idea is the little hand wheel that you open will allow steam to come in from the turret and go through the stem all the way out, come out through the boiler, and come out through this bronze piece here that we made last weekend. So several parts to make, and we'll see if we can't finish up this this valve this weekend. Just stopping to show what I do is, this is a piece of 3/8 inch hex, and I just rough shape the bonnet, is what I call it, before I do any drilling and tapping. So I've used a variation of regular lathe cutting tools, cutoff tool, and some round nose tools and some files to get it to this pretty close shape, because you might as well before you start weakening it by drilling through and tapping it and threading this portion here. So here we've got the part all formed up. I've drilled it all the way through and tapped inside like it's called for on the Bailie plans, threaded the outside here, formed all this, and we're within a couple thou of the final diameter here. I just need to cut it off and then flip it around and get down to that 3/16 inch diameter, and then thread this for the cap. Finished the bonnet. Now I'm making the cap, little 1/4 inch hex brass, and it's threaded 1032 to go on this portion, drilled through 128, which is a number 30. I'm getting ready to cut it off at 200 thou. Well, I did want to show one thing. Here's the part itself before I cut it off and clean it up. But what I do with my conventional taps and stuff, I keep the little cardboard, and I keep the appropriate drill and the tap, and then in this particular instance I must have broken off this 1032 tap, the tip of it, at some point in time, and rather than discarding it, there was plenty left. As you can see, I ground it down so that only a thread is wasted, and I use it as my bottoming tap. So just a thought for you. And then I keep them in a Plano little fishing tackle, which is exactly where it goes, right here. So I've got all my conventional sizes in here. I keep my miniature ones other places, but that's how I organize my taps and tapping size drills. Here's the top adapter, the steam, what will be the steam inlet. This is a 250 thou portion over here, where the steam supply will come into. I just use a center drill to create the pocket there for the cone, and then I've used my cutoff tool to work this diameter down to 1/4 inch here, and I just have a 1/16 of an inch little spacer there from the hex and I'm going to move this out, and we'll cut this off at 150 thou to go in. Then I can turn this around and thread this portion. Well, this is kind of like what the valve stem is supposed to look like, but I messed up and I made this one way too short, so oh well, I'll save it because it's generally good. If I ever needed a smaller one. But what I'm going to do is start over again. I'll just cut off a piece of stainless steel 1.5 inches long. I'm going to make the cone tip. I won't bother showing all this stuff because it's similar to the other things I've made, but I'm going to do just a little piece at a time. I'll bring you back as we make our progress. Just a note, so the point is almost completely machined here. There will be a few more passes needed. What I'm going to do is stop now and put the threads on this, and then I'll come back and finish up, make the last couple of passes just to make sure that the cone is the cleanest and nicest part, because the threads, when you cut the threads, they do upset the metal a little bit, and you want to make sure the cone is clean and separated from the threaded portion. This is what I'm talking about, using the tailstock die holder to thread the number 10 threads on here. It's 1024, so it's a coarse thread. You can see it really comes into the cone area, so that's why I left a little bit. Also, I threaded a little bit more than 400 thousandths of an inch so that I can, when the cone gets done, then I'll have to thin this part here. I can just be exact about leaving the 400 thou. But now I'm going to reposition the lathe cutting tool and clean up the cone. Alright, this stem's come out a lot better so far. Machined it down to an 1/8 inch and filed it smooth. I've machined the little tang at the end down to just under 90 thousandths so I could thread it for the 256, and I just put a little scribe line at 700 thou out from where the threads are. The threads are right inside the collet, so that's the portion in blue there that can get filed down to a square for the hand wheel. Here's the stainless steel valve stem. I went ahead and milled this down, obviously using the 5C collet block. You can see what I did to support it. I put it in backwards through an 1/8 inch collet, and gives it pretty good support. I was able to machine that down, so I have a nice little 88 thou roughly square there, and I can proceed with drilling and filing out square the handle. Alright, we've drilled the little handle with the number 36 drill, and now we can take it out and file it square. Here's the completed valve screw with the handle and a little nut, 256 nut on it. So we're going to try to assemble everything together, and I am going to silver solder one of the fittings into the body, so I'll show you that in a minute. Alright, I guess this will be the last segment of the episode. Thanks for watching, everybody. It's really interesting. You can see the pieces that I made out of bronze after they've been heated, like this one here, this adapter. When I heated it and silver soldered it onto the bronze body, you can really see that coppery color in contrast to the brass parts that comprise the rest of the assembly. So, and it's funny, this is bronze as well, but it hasn't turned coppery. I haven't soldered it in. This will be screwed into the front of the boiler in the smoke box area. So, have a great week, everybody. Thanks for following along.